Save. So I hope there is no problem regarding Newton's forward backward interpolation, right? So Newton's forward difference interpolation is used to find value of function y equal to fx, where x lies at the beginning of the data. Okay, so this is a convention that we remember or we use, and NBDI, Newton's forward backward difference interpolation, is used to find value of function y equal to fx, where x lies at the end of the data. So this is a convention, this is not a thumb rule. It's not that if you use forward for x value which is at the end of the data, you will not get answer. Okay, it's not like that. Of course, you can use both the interpolation techniques for any x which is in the range. Okay, so Newton's forward and backward, you have to remember very important thing that NFDI and NBDI formulae are applicable for equally spaced data. For equally spaced data. Do you understand this? Equally spaced data means x values are equidistant. X values are equidistant. Girls, do you write down all these things, whatever I am writing?
Yes, ma'am. Yes, ma'am.
Because see, first year BSc also I told them, especially for mathematics, you should not rely on your screenshots and all these things, okay? Because anything can happen anytime to any device. If you are taking screenshots on your mobile and you will think that you will write it later on and something happens to your mobile, then whole data is lost. Okay, so please do not rely. Technology is the best and the ultimate ones we are using nowadays. But still, you should not rely on that for such subjects. Okay, you should write it down because I am writing it down very neatly for you. Okay. Yeah, can we move ahead? These three things you have to remember. So now we will see the next chapter we are having in the series of interpolation. So this might be 1, 2, 3, 4th chapter. No, 1, 2. The first chapter was expressions. Yeah, fifth chapter. Yeah, fifth chapter in our syllabus. Okay, interpolation for unequally spaced data. Okay, this might not be the exact title of the chapter, but this is what we are going to do ultimately. Interpolation for unequally spaced data. Okay, so here basically we are going to see two things. The very first one is Lagrange's interpolation. And the second one is Newton's divided difference interpolation. So it is written as NDDI, Newton's divided difference interpolation. Okay. So both these formulae work when data is unequally spaced as well as equally spaced. Okay, but usually we use it for unequally spaced data. If it is equally spaced, then we prefer to use Newton's forward or backward. Okay, so you remember we had the values of this type. The x values were a plus h. You remember a plus 2h in case of equally spaced data, right? Do you remember this?
Yes, ma'am.
X values you used to take as a plus h, a plus 2h, because you knew that the distance, the difference between two consecutive x values is h, right? Here also, the difference between these two, a plus 2h minus a plus h, will become h. So you knew that the difference is constant. That's why we call it as equally spaced data. And h plays an important trail role in your formula, right? Yes or no? H is not there in the formula, in both the formulae rather, Newton's forward and backward directly. When you write the final formula, you don't find h there, but you find the formula or you write the formula in terms of u. But your u involves h. U is x minus a upon h, right? In case of forward. And in case of backward, it is u minus x minus a plus nh upon h. So h is always there. It plays an important role in the equally spaced data. Okay, but here, as we are going to consider unequally spaced data, that means the two consecutive x values need not have a difference of h. The difference need not be constant, and that's why there will be no h, nothing called as h in the formula. Do you understand this? Do you understand what I'm saying? You need to respond me.
Ma'am, understood.
So now there will be no h in the formula, okay, but we will be having different x values which need not be equidistant, so we can call them as x naught, x1 up to xn. Like Newton's forward and backward, we will be having again n plus 1 values. So tell me, if you have three values with you, 3 points with you, what will be the maximum degree you can achieve of the polynomial? When you consider any polynomial, say x square plus 2x plus 4, right? This is a degree 2 polynomial. There are three terms, but there is a Shraddha Surve left the meeting. Okay. There is a constant term, right? So when you have three terms, you can have a polynomial of degree maximum 2. Are you getting me?
Yes, ma'am.
When you have four values, what will be the maximum degree you can achieve?
Three,
When you have three values, what will be the degree?
four,
4. Then, if you have n plus 1 values, then
n is the degree.
n is the degree. You understand this? So, we will be
Yes.
having now, uh, just a minute. Yeah, so we will be having n plus 1 points now. So the degree of the polynomial, maximum degree of the polynomial will be n. Is that clear to you all?
Yes, ma'am.
And how to achieve an n degree polynomial? When you multiply x n times, right? When you multiply x n times, x into x into x n times. So here what we want to do, suppose I have such this kind of data with me. This is x, this is fx, fx is nothing but y. My x values are 0, 3, 0, 3, say 4, say then 8, then say 13, something like this. Okay. So is this equally spaced data? These x values are equally spaced?
No, ma'am.
No. The difference between these
No.
two is 3. The difference between these two is 1. Difference between these two is 4. Difference between these two is 5. So we want to find out a polynomial using these x values and y values which fits the data. That means when you will put x is equal to 0 in that polynomial, the y value, the fx value should be 0. When you will put x equal to 3, you should get the value of the polynomial as 27. When you will get substitute x equal to 4, you should get 96 and so on and so forth. As you have 5 values here, the maximum degree which you can expect, I am saying, is 4. Is that okay? Are you getting it? Are you getting it? Girls, are you getting it?
Ma'am, please repeat once
Yes,
again.
ma'am.
Who is saying, who is telling to repeat? Riddhi?
Ma'am, Riddhi.
देखो एक एक करके मीटिंग लेफ्ट कर रहे हो के सी रिद्धि वी हैव 5 values, okay? Are they equally spaced? Tell me. 0, 3, 4, 8, and 9. Yes, you understand? What is the difference between these two? 3. Hmm?
Yes, ma'am.
Now, here the difference is 1. Here the difference is 4. Here the difference is 5. So there is no H. No H, right? Are you getting this? So I will not call these as A plus H, A plus 2H. ऐसे में इसे कॉल नहीं करूंगी. समझ में आ रहा है? Are you getting it?
Yes, ma'am.
Instead of that, I will call them as x naught. This is my x1, x2, this is x3, and this is x4. Do you understand it? So you are starting from 0 and you are at the end, you have x4. So total 5 values are there and you will try to find out a polynomial basically in Newton's forward backward also. You are finding a polynomial only, but we are putting x value in the in the beginning only. When you calculate u, that time x minus a upon h, suppose Newton's forward you are doing. That time you substitute x value, right? जैसे कि हम find out population of the town in the year so and so, तो आप वो x substitute करते थे रिद्धि यहाँ पे, इसलिए ये u कांस्टेंट आता था आपका. लेकिन अगर आपने x की जगह कुछ भी नहीं सब्सटीट्यूट किया, सपोज x माइनस कुछ 19, 20, 19, 11 था हमारा सपोज एंड h was 10, so this u will always be remain in terms of x. So using Newton's forward backward also you are finding out a polynomial only which connects x and y. Riddhi, are you getting me?
Yes, ma'am.
ऐसे polynomial में y का फॉर्मूला लिखना है in terms of x, and this fx is nothing but a polynomial expression. Okay, so we will try to get a polynomial which fits the data. मतलब when you substitute x equal to 0, the answer of the polynomial must be 0. When you will substitute x equal to 3, the answer must be 27. When x equal to 4, answer must be 96, and so on. Okay,
Yes, ma'am.
let us see Lagrange's interpolation. Lagrange's interpolation. Correct. First. Just a minute. Yes. So let us see Lagrange's interpolation. Write with me. Let y equal to f of x be continuous. This is important. Be continuous and differentiable n plus 1 times in the interval a comma b. Given how many values we are given? n plus 1 na? Do you understand this? n plus 1 values कैसे हैं हमारे पास? Because we are starting from x naught and the last value will be xn, x value. Okay, accordingly we will have y values. So given n plus 1 values, क्या क्या values है? x naught comma fx naught. Okay, next will be x1 comma fx1. Next will be x2 comma fx2, and so on. You have up to xn comma fxn. So totally n plus 1 values are there, and where the arguments, the x values, we call them as arguments. Okay, where the arguments x naught, x1, x2, and so on, xn, are not necessarily equally spaced. Okay, that means they can be, but not necessarily equally spaced. That is, difference between two consecutive x values, difference between two consecutive x values need not be constant, need not be same. Do you understand this? Yeah, next. Finished writing this?
Yes.
Be quick. So this formula has a longer expression, okay? But it's very easy to use. The working rule is very easy. You just need to write long expressions. Yeah. Next, as n plus 1 values of fx are given, nth differences are constant, right? Yes or no? ये फंडामेंटल थियरम हमने देखा था ना?
Yes, ma'am.
Constant and n plus 1th differences are 0. Let P and X be a polynomial.
Ma'am, that n plus 1 difference will be constant, no?
No. Try to recall. Because see, you start from x0, na? x0, x1, x2, x3, x4. So when you have 5 values, the fourth order differences will be constant. Delta raised to 4 में आपके पास एक ही value आएगी. When you have 5 values, okay? When you have 5 values, are you getting me?
Yes, ma'am. Till fourth value will get constant and
The
value
differences will be 0. Yes. Okay.
no, ma'am, because you wrote n plus 1 difference are constant. That's why I thought.
समझा क्या? एक मिनट है गर्ल्स, 1 minute. 1 minute. Yes. हाँ, doubt cleared girls? Yes or no?
Yes, ma'am.
Yes, ma'am.
Let P and X be a polynomial in X of degree n. So when you have n plus 1 values, the degree of the polynomial would be n. You remember in case of Newton's forward, also we had written the polynomial in a specific manner, and then we later on calculated those constants a0, a1 up to an. Similarly, we will do here, but here our constants will not be in terms of forward or backward differences. Okay? We write Pnx in the following form. Pnx is equal to a naught. So when I am using a naught here, 0, that time I will skip the first value of x. Okay? I will make each term of degree n. तो जैसे मैंने पूछा आपको, how will you have x raised to n? When you multiply x n times, है ना? When you multiply x n times, x into x ऐसे आप जब n times करोगे, तब आपको क्या मिलेगा? What you will get? X raised to n. Getting it? So here also, I am trying to write every term as an n degree term. So I should have x how many times? N times. And I want to make use of the values which are given to me. because I want to find out the polynomial which fits to the given data. So I will make, मेरे पास कितने values है बताओ? How many x values I have? n plus 1, right? Right? Yes or no? I have n plus 1
Yes,
values.
ma'am.
So
Yes, ma'am.
at a time, how many x I will use? How many x values I should use? Only n out of that, right? अदरवाइज डिग्री क्या होगी पॉलिनोमियल की? अगर मैंने सारे के सारे एक्स नॉट से लेके एक्स एन तक के सारे वैल्यूज यूज किए तो हाउ मेनी वैल्यूज आर देयर हियर? एन प्लस 1 हुए ना ये?
Yes, ma'am.
इन सबका मैंने मल्टीप्लीकेशन में लेती बैठी ऐसे, तो ये n प्लस 1 डिग्री हो जाएगी पॉलिनोमियल की. समझ में आ रहा है क्या? I want to make use of only n terms at a time. Okay? So ये मैं कैसे कर रही हूं देखो, x minus x1 into x minus x2 and so on x minus xn. Which number I skipped here? कौन सा नंबर मैंने स्किप किया यहाँ पे या ब्रैकेट स्किप किया?
Minus x naught.
Yes, I skipped x minus x0. Do you understand this? And here what is the suffix? A0. समझा ये? इससे क्या हो रहा है देखो, x into x into x, x raised to n की टर्म क्रिएट हुई कि नहीं? बाकी कुछ भी हो जाए, हाईएस्ट डिग्री की टर्म, बाकी और पॉलिनोमियल लिखेंगे हम, बट हाईएस्ट डिग्री पॉलिनोमियल, हाईएस्ट डिग्री टर्म क्या होगी? x raised to n होगी. ओके? सिमिलरली सो प्लस a1, लेकिन अभी हमें ऐसे नहीं रुकना है, हमें सारी वैल्यूज वन बाय वन यूज करनी है. तो जब मैं a1 कहूंगी तब मैं क्या करूंगी? आई विल स्किप x माइनस x1 टर्म. अगेन आई विल हैव n वैल्यूज ओनली आउट ऑफ n प्लस 1, तो मैं सेकेंड वैल्यू स्किप करूंगी. ये समझ में आ रहा है क्या?
हाँ मैम.
प्लस a2 बताओ अभी. a2 क्या होगा?
x minus x1
x0
into x minus x1 dot x minus x
नहीं, अभी
x minus x3
x3 लिखना चाहिए आपको, क्योंकि आपको x माइनस x2 स्किप करना है, फिर डॉट डॉट देके x माइनस xn प्लस अभी लास्ट टर्म क्या होगी मेरी? an. अभी क्या स्किप करेंगे हम? What we should skip?
x minus
Ten.
X minus xn we should skip, and therefore last will be x minus xn.
Minus.
Put this equation number 1. I am just trying to generate a polynomial of degree n. So in every term, I have collected n brackets which contain x. So ultimately, that is going to produce x raised to n terms in every term. Okay? और फिर आपके a0 a1 3 मिनट्स बचे हैं गर्ल्स सिर्फ. सो व्हाट आर योर a0 a1? वेयर a0 a1 a2 अप टू ये कॉन्स्टेंट्स आपने कैसे चूज करने चाहिए? ये आपके डेटा को फिट करने चाहिए, है ना? आर कॉन्स्टेंट्स एंड चोजन such that what? When you will substitute x equal to x naught in this thing, x equal to x naught जब आप substitute करोगे तब आपको आंसर मिलना चाहिए fx naught, जो कुछ आपको दिया गया है. ओके? जब आप इसमें x1 डालोगे तब आपको मिलना चाहिए fx1 का वैल्यू, जो मैं यहाँ पे कह रही थी. देखो कि आपने 0 सब्स्टिट्यूट किया तो आपको आंसर मिलना चाहिए 0 इस डेटा के लिए. आपने 3 सब्स्टिट्यूट किया तो आपको आंसर मिलना चाहिए 27. डू यू अंडरस्टैंड दिस गर्ल्स? When you substitute x equal to x2, you should get
Yes, ma'am.
ऐसे. Huh? Pn x2 should be equal to fx2 and so on. Pn xn should be equal to fxn. This is how the constants must be chosen. तो अभी हम क्या करेंगे? We will substitute one by one. I think अभी हम रुकेंगे. Okay? Students, do you listen to me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
I'll continue with this derivation. Okay? We will continue with this derivation.